Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a question, multiple choice number 10, extracted from 2018 time zone 2 in May, right? So it's asking for another typical type of question from topic 4, especially the sketching of a Lewis structure. Let's see. They're asking which species down here has the longest, first of all, longest is the keyword, C to O bond length, right? So the first concept that extracted from the question is that, remember, the longer the bond length that is, the weaker the bond strength. So the longest bond length here we're regarding as the weakest bond strength. Because only if the two elements are having the weakest interaction, the distance between the two bonded atoms will be furthest away from each other, according to the logic of the concept behind covalent bond, right? So that means the bond order should be the minimum, like the order of 1 will be longer than the order of 2, longer than the order of 3. So that's why, let's see, for each of the Lewis structure, be able to sketch the Lewis structure, and this is not supposed to be difficult, as most of the choices, as you can see, are just standardized examples, right? The first one, for A, if we sketch the Lewis structure, you realize that C and O is basically having a double bond. In addition, one of the bond addition will be a dative covalent bond, and then two ways having each a lone pair electrons, right? So in this case, we can see that basically dative still count as one simple covalent bond, so that's why the bond order is going to be 3. So that means the bond should be quite strong, so shouldn't be our answer, right? For the choice of B, typical organic compounds, right? If you sketch the bond out in a Lewis structure, you realize that 3 CH bonds and then plus 1 of the CO and then OH bond, right? And then 2 lone pairs are remaining in the case of oxygen. So that's why here, between C and OA, this is going to be just a single bond. Really high chance. For C, let's look at it further. So CH3CO2 minus, so which is another typical example from here, having the C double bond O, single bond O, and then one of the negative goes to one with just a single bond, and then 3 lone pair electrons, and then 2 lone pair back on the normal oxygen. In this case, if students still remember, this has been tested before, that this ethanoate ions is having a bond order of 1.5 within these two CO area because of a pretty important concept called the delocalization. So if you realize in this case, you should realize that this is of a jumping pi bond. So that's why the bond order in this case should be 1.5 between the C and O. So for the B, choice B, so this is going to be 1. And for the choice A, this is going to be 3 in terms of bond order. So finally, look up for D, you realize that this is going to be an aldehyde, having a CO double bond and 2 sides of H's, right? Yeah, and in this case, no doubt, the CO area is a bond order of 2. So that's why the one that having the weakest bond should go for B. So answer B.